So the first thing to do in this problem is to see where we're going to have a shift and where we're not. As it states in the problem, if bouncing off a lower index of refraction from a lower off of a higher, there'll be that pi radians shift. So I just quick label my indexes of refraction over here so I don't lose track. And we can see that wave A, going from air to the soap, will have the shift, but B, going from bouncing from the soap off of the air, will not have a shift. So when figuring out our phase difference, we have our equation here, and we can see that the path difference will be this 2 pi over the wavelength times d, which is the thickness of the soap bubble, plus this, this shift of pi that we see in wave A. So we come down here, and the first thing to do is to calculate, so we're given, obviously because we see green, we see that 550, that means that's the wavelength in the air, so we have to calculate the wavelength in the soap, and we use this equation right here, saying that the index of refraction times the wavelength is going to be equal in both situations. We do some algebra, and we end up getting the wavelength in the soap is this number, 387.32 nanometers. Then all we have to do is put that into our equation, and we set that equal to 2 pi because we are given that it is constructively adding. So then that's why we have a 2 pi there, and we do our algebra. So we end up with an equation that d equals the wavelength divided by 2, so then d then equals 193.66 nanometers.